All right, class. So to finish up our lecture on Chapter 7, I just want to go through some statistical sampling methods for you. And again, all of these things can be found within your book. So please definitely review these as well. So the first group we'll look at would be stratified random sampling. The name is derived from the different strata, different layers of the Earth, so you can think about it that way. But the big thing you need to know about stratified random sampling is that the results are obtained when we put all of the same single characteristic of a group all within the same group. And so the groups themselves tend to be very homogeneous. There's one characteristic that is common among all those in the same group or the same strata. So for example, we could group folks by their age, and the age would be the similarity. It could be by race or gender or religion or national origin or department within the company or geographical location that they work in or industry type, so on. So again, with stratified random sampling, what we're going to do is we're going to put everyone into a group. And then from the groups, we will then find what similar characteristic there is, and then we'll simply take a simple random sample from the different strata, and that will ensure that we get a random sampling that would well reflect the population. Keep in mind with our sampling techniques, what we're trying to do is use inferential statistics to infer things back onto the population. And so in order to do that, we need to make sure that we have a good representation of the entire population. Okay. The next group besides strata would be cluster sampling. This is more or less the opposite of strata. Strata, again, we're grouping people together in the same, one characteristic is the same, and we group them by that characteristic. Cluster sampling is we actually want each of the subgroups to be very diverse. And so from that subgroup, we will then grab a simple random sample. So again, strata, we saw the groups were very homogeneous. With cluster sampling, the groups would be very heterogeneous in that, again, they would all be different from each other. And by doing that within these smaller groups, we could then get a simple random sample and hopefully get a good representation of the population. We normally see this in city blocks where we'll have a diverse group within a few of the city blocks, and from that group we'll be able to kind of get a small representation of the overall population. Okay. The next one after that is systematic sampling. This is pretty simple, and the idea is simply saying, hey, listen, if you have some large population, and again, the large population will be denoted by our N, big N, versus the sample size we're looking for, little n, we simply say, hey, look, take N, the sample you're looking for, divided by the whole population, and start counting off. And so we are looking for example, we have 50 of our sample out of 200. We're simply going to take every fourth person, and all of a sudden that gives us a very systematic way to sample through our population, again ensuring we get a good representation of the entire population. Some of the advantages, again, it's usually easier to identify than it would be to a simple random sample or used. Going through a phone book, if you look at the AU Direct would be an example as well, right? With all the phone numbers, or I don't know if we have that anymore, but emails of all the students, list them out A through Z, and then simply take, every eighth person, and all of a sudden we'll have a good representation, a good sampling technique. Okay. Another one would be convenience sampling. So again, it is a non-probability sampling technique. That means that we cannot use some of the statistical methods that we've looked at with normal distribution. Non-probability or non-statistic or non-parabolic is another name for that. So all those terms will be used throughout the text and in your career as well. So it is exactly as it sounds. It is a convenient sample. So professor conducting research might use student volunteers and constitute it as a sample. The problem is that it is not a random sample. It is not a true representation of the population. And so therefore, again, I'd have a problem doing that. I wouldn't ensure that I would get a representation of the entire population. Okay. And then judgment sampling would be one of our last ones here, where again, we kind of use our own subjective method to figure out, hey, who is the most who makes the most sense to ask this question to? And so one of the examples here, a reporter might sample 3 or 4 senators, judging them as reflecting the general opinion of the Senate, right? So we didn't take a statistical sample. We didn't ask, a sample size of 40 people here. We simply just said, hey, listen, let's talk to 3 or 4 influential people. And we know that those are the leaders of each individual respective party. And based upon those conversations, we will assume that the rest of the party will also feel similar. So does that make sense? So again, it's really the difference between convenience sampling is we're asking those that are close to us, those that are near to us, maybe an audience or a sample that we can get in front of and do it quickly, versus a judgment sampling is really looking at things like, hey, how do I get a good representation, but not a statistical representation of the population? Okay. Recommendation, again, this is pretty important, that it is recommended that probability sampling methods, simple random sample, stratified, cluster, and systematic can be used. And so this means that we can actually use our normal distribution. We can use our statistical methods that we've been learning in class. And then everything else is really very subjective. So the convenience and the judgment, we cannot use statistical methods. These are non-probability methods. So it's not like you can run a standard deviation on a judgment sample, or a standard deviation, a probability using normal distribution for a convenience sample. It just won't work that way. So, and then the last slide here is really just looking at the stratified versus clustering. The biggest thing, again, stratified, they are the same. The subgroups are the same, and there is differences between the groups. Cluster is the subgroups are different. They're all made up of different populations, but the groups themselves, between each of the groups, they all look very similar because, again, the diversity is within each of the groups. So hopefully that makes sense. And that's really it about the sampling techniques. All right, so I thought we'd use some time to walk through a couple of the problems. Again, I know we went through those last few slides rather quickly, but if you need additional time, go back through, pause the video, take your notes, and that way you'll have all the information you need. Re-listen to them. That'd be great. So let's work some problems. Again, I'm going to encourage you to pause the video now, read through the question, attempt it on your own, and then we'll walk through it. So. Okay, the driving distance for the top 100 golfers of the PGA Tour is between 284.7 and 310.6 yards. Assume that the driving distance for these golfers is uniformly distributed over this interval. What is the probability that the driving distance for one of these golfers is at least 300 yards? So the first thing I'd like you to do is draw out your uniform distribution, okay? And so we know that if it's uniformly distributed, we're going to have A and we'll have B. So in this case, it would be 284.7 and 310.6. And so what we will do is we will do 1 over, in order to find the height, we're going to do 1 over B minus A. Right? In order to find the height of this uniform distribution right here, 1 over B minus A. Sorry for the poor penmanship there, but when you do the math, you'll notice that the height would be 1 over 25.9. 25.9. Okay? So now what we're looking for is what is the probability that it would be at least 300, at least 300. So that's 300 or more. So let's just call 300 right here, and we'll do 300. So our base is 310.6, and the height, so it's actually not 310, I'm sorry, but 10.6 times 1 over 25.9. And that will be our probability, 1 over 25.9, okay? So do the math real fast, see what you get. So perfect. Again, we're going to take our base times height. And so this 0.0386 is equivalent to 1 over 25.9. And so we multiply that by the 10.6, and we get to about a 40.92% chance. All right. All right, next question, still from chapter 6 here. Is the lack of sleep causing traffic fatalities? A study conducted on the auspices of the National Highway Traffic Safety Administration found that the average number of fatal crashes caused by drowsy drivers each year was 1,550. Assume the annual number of fatal crashes per year is normally distributed with a standard deviation of 300. What is the probability of fewer than 1,000 fatal crashes in a year? Again, this is from chapter 6, but what I want you to see here, because the question becomes is, hold on, I've got two formulas for z. I know it's normal distribution, but I have x minus the mu over the standard deviation. But I also have z is equal to x bar minus the mu over the standard deviation divided by the square root of n, right? And so what we need to figure out for ourselves here is to understand what's the correct formula to use. Well, this 1,550 each year is going to be looked at from our perspective as the population average, right? And we really don't have a sample average, and so we know that we'll be using this z-score here. We'll be using that z-score calculation. So what is the probability that fewer than 1,000 fatal crashes in a year? Fewer than 1,000? Well, what I need to do, I need to solve for z, where z is equal to 1,000 minus 1,550 divided by the standard deviation of 300. And when I do that math, I get to a z-score of 1.83. And so now I need to go in and look that up. I need to figure out what is the p-value associated with 1.83 blue shift z to p, and I get to 0.9664. But what I care about, what is the probability that fewer than 1,000 fatal crashes would occur, right? Oh, I'm sorry, this is a negative number, isn't it? That's negative. Whoops, there's my problem. So it's a 1.83 negative z to p, and now I get to a 0.0336. The probability, if the standard deviation is 300, population standard deviation is 300, and we have a population average of 1,550, what's the chance of getting less than 1,000 in a year? It's about a 3% chance. Okay, so hopefully that makes sense. For the next question, I'm going to pause it here for a second, and I want you guys to work that out. Okay, so for this one, for a year to be in the upper 5% with respect to the number of fatal crashes, how many fatal crashes would have to occur? So again, friends, what we're looking for here is for x. We need to solve for x. And so what we're going to find is, how do I figure out, well, what number is associated with the upper 5%? Well, if I draw out my normal distribution, right, and what I'm looking for is 5% here, and I'm looking for 95% here. And so I need to figure out what is the z-score that is associated right here. Well, I know the probability is 5%. And so I can type in 0.95 blue shift inverse p to z, and that'll tell me that that z-score is equal to 1.64. On your calculator, it'll be 1.6449. But what we're going to learn as is 1.645. 1.645. Okay? And so now all of a sudden, I can easily solve for x by taking, whoops. Okay, come on. X is equal to 115 plus, actually let's just do it the long way. Let me do it the long way. So we have 1.645 is equal to x minus 1550 divided by the standard deviation of 300. I need to multiply both sides by 300. Okay, so 300 times 1.645 is equal to 493.9. 0.5 is equal to x minus 1550 plus 1550 to both sides, plus 1550. And now x will equal 2,043. Oops. 2,043.5. Okay. So again, just a review from chapter 6, but hopefully that helps everyone. Okay, another review question. From a group of 12 students, we want to select a random sample of 4 students to serve on a university committee. How many different random samples of 4 students can be selected? So first question becomes does the order matter? And so I want you to figure that out, pause it, and try to solve this out. Okay, so what we're looking for is from these 4 students, a group of 12 students, group of 12, we want to randomly select 4. How many different groups can we make? So from 12, choose 4. From 12, choose 4. And so again, we can work out the math, or you can simply use your calculator with your combination problem. From 12, choose 4. Okay, so 495. Okay, I'm going to pause right now. I do want to go over the labs real fast with you as well. Hold on just a second. Let me pull that up. Okay, so this is lab from chapter 5, information. So just want to run through this real fast. This is the information you were given, the wind conditions and percentage of accidents. You were told in the problem that you needed to use X is 0, 1, 2, 3, and 4. And so what we need to do for answer A, the probability distribution, or the f of x, we need to change from a percentage to a decimal, and then we need to use these decimals all the way through. I think some of the folks in the lab, they were actually using some numbers here that really didn't. They were using the whole numbers here, and that's going to throw off your variance and standard deviation. We'll get to that point. So in order to find the expected value, what we're going to do is we're going to take the f of x, or 0.096, which is just this 9.6 as a decimal, not a percentage. We multiply that by 0, and so we get to 0. We take the 0.57 times 1. We take the 0.238 times 2, the 0.077 times 3. Again, you can see all these, and then we get all the way down here to 0.019 times 4, and we have our total here. So the expected value is 1.35. Again, that should make sense because it looks like as we have about 57% of accidents here in the light condition, and so we would expect the vast majority to be somewhere between the 1 and the 2, and sure enough, it is 1.353. In order to find the variance, all we're going to do is we're going to walk through our steps here, right? So we have x minus the mu, okay? X minus the mu. So in this case, again, our mu is the expected value of 1.353. So 0x minus the mu gets us our negative value. We do the exact same thing moving down here. We take 1 minus the 1.353, which would give us negative 0.353, and on we go. We square it, take rid of the negative, and then we multiply it yet again by the probability, the f of x. Okay, again, if you multiply it by this percentage here, it's going to throw off your number. So I think a lot of folks did that, but just keep that in mind that this needs to be a decimal place here. Okay, so from there, we simply can multiply those out, and then the last step is we just sum them up. So we sum up all of our values here. And then we take the square root of the variance to get to the standard deviation of 0.89. So again, that answers our question, the expected value, as well as the C and the D for variance and standard deviation. And then finally for D, it says, since the expected value of 1.353 would indicate that the wind conditions when an accident is most likely to occur would be slightly to moderate, somewhere in that range. Again, this is kind of interesting. Most people think, most accidents happen in a storm, but the reality is that there's a lot more boaters that are out during nice wind conditions versus in storm conditions. Everyone knows to kind of come in and stay off the water. And so that would be something that the data would show that may be counterintuitive to some folks. So, okay, for question 2, again, binomial probability. And the answer for A is simply that, hey, since employees are selected at random, the probability is the same from trial to trial, and the trials are independent. The 2 outcomes per trial are the loyal and not loyal. These are all the all the conditions that we need for a binomial distribution. So it is looking for in B the number of trials, the probability of success, and the number of successes again is 0. And so we can just use our binom.dist formula. And the last piece that we need here is false. Okay, is false. And so what we get there is we get what's the probability that would be exactly 0, would be about 5% chance. So there's a 5.6313% chance that none of the employees will say that they are loyal to this company. For C, the question is at least 2. So that means 2 or more. Okay, so 2 or more. So there's a couple ways we can do this. You can find out 2, 3, 4, 5, 6, 7, 8, 9, 10. Or you can simply take 0 and 1 and then do 1 minus that, and that'll also give you the answer. All right. So here we have, we already found 0 up here at the 0.05634. And then we can find 1, and then we can add those up, and then we can just subtract the 1 minus that number. And that'll give us exactly what we need, right? 1 minus this 0.24, and that'll also give us the probability, about 75% chance. Okay. All right, so for lab 6, this is really asking about trading volumes and trying to figure out if using normal distribution, what some of these questions are. So if we look at question 1, compute the mean and the standard deviation using estimates to the population mean and standard deviation. Compute the standard deviation 2 ways, by hand, and then use an Excel standard deviation function. So first thing we need to do is we need to figure out the average. So we have an average function for that here in Excel, equals average, and we simply take all of those and we figure out what the average is, which is 199.69. A lot of you got to 200 just because of rounding, so keep that in mind. Always make sure you go out a couple different decimal places here, okay? And then once we get to the X bar, the sample average, we simply take the difference of 214 less the 199. Double click on this so you can see the 214 minus the 199, and we get to 14.3. We square that number, and then we sum all of those up. So we do the exact same thing here. 202 minus the 199 is 2.308. We square that number. The 174 minus the 199, we square that number, and we add them all up. Here's our sum of all of those values. For the variance, we need to take the n minus 1, right? So we are going to take, in this case, we need to count these up. We had 13, and so we take n minus 1, which is 12, and then we take the square root of that for a standard deviation of 26.04, and then we confirm that with our Excel. Again, the formula in Excel is standarddiv.s, and that is a sample. Those that used standard or stdiv.p, that's for the population, so that would throw off your standard deviation calculation. Okay. Question 2, again, these are all kind of review for us here. What is the probability that on a randomly selected day in the early morning trading will be less than 180 million shares? So again, you should be thinking in your mind, drawing out your normal distribution, and we would see less than 180 million shares. So our X, a standard deviation, and our X bar, again, when we do that math, we get to a negative 0.77. So I got to a negative, again, when I use a standardized feature here in Excel, I get to a negative 0.67805, which rounds up to a negative 0.77. We can look that up in the book, or Excel has a norm.dist function here, norm.dist, where it just simply puts in these items and it tells me what I need. So again, I put in my X, the standard deviation, and the sample, and that gives me what is that probability. So the probability would be about 22.6% from the book, but because this is using this exact figure here, this 0.6 or 76805, there's just a little bit of a difference between what we see in the book and what we see in Excel. Nothing crazy, just a little bit of a difference. Question 3 is very similar to question 2, except for in the early morning volume will exceed 230 million. So really now, again, I'm stopping, I'm thinking through my normal distribution. I am looking for the area to the right. And so because it's cumulative, I know at the end of this thing, I'm gonna have to take 1 minus that number to get to the total, okay? So we do the exact same process. We come in here and we can figure out using Excel, norm.dist. We take 1 minus that figure and we'll recognize that 230 million would be about a 12%. Okay, having 12% of 230 million shares traded in the morning or more would be about a 12% chance that would happen. All right, again, the z-squared we get is 1.15. That converts to 0.8749. And then we take 1 minus that to get to the answer that we're looking for. Okay, again, some small differences here between what's in the book and what's in Excel, just because Excel is going to a lot more decimal places. Okay, the last question, question 4, is how many shares would need to be traded in the early morning shares on a particular day to be among the busiest 5%? This is exactly like the previous problem we did. So I've got 95% on one side and 5% on the right hand side. So I need to figure out what is the z-score associated with 95%. Well, sure enough, it is 1.645. And so I just set up my problem again, right? The z-score is 1.645 is equal to x minus mu over the standard deviation, and we just solve out from there. And when we do that, we get to 242 million shares. There is an Excel function called norm.inverse, which gives me the probability. Tell me exactly what that is, the 95%. What is the average? Okay. And then from here, this is also looking for the standard deviation. And from that, it'll tell me what the inverse is. So this is equivalent going from P to Z on our calculator. I hope that helps, guys. This is pretty important stuff. Again, we're doing this in review problems. You're seeing this in labs. That should be an indication that if you're not picking these things up, you need to ask questions in class, you need to come see me, or you just need to work more problems on your own so it becomes pretty fluid for you. All right, that's it for this lecture. And again, please pause this video, rewatch it as you need to. Make sure you're getting all your notes in, and I'll see you guys the next time.